Today's lesson is on scientific notation, and this is the first of 2 days we're going to be working on this. Today, all we're going to do is convert numbers between scientific notation and standard form. So what is scientific notation? It is a way of expressing really big numbers or really small numbers. Most often used in scientific calculations where the analysis must be very precise. So for example, the distance from the Earth to the Sun, I believe, is 93 million miles. It's a big number. This offers a way of writing it a little bit smaller. And just think about other really big, really small, distances or amounts. Distance from Neptune to the Sun. The size of a small cell in a small animal will be really tiny. This allows us a way of, lessening the zeros and making the numbers more manageable. So there are two parts of a number in scientific notation. The first part, we have a number between 1 and 10. And then the second part is a power of 10. So the form is going to be n, which is some number, do this, between 1 and 10, times 10 to some power of 10. That can change. The 10 will always be there, though. That is a given and automatic. So to change a number from standard form into scientific notation, there's a decimal point involved in every number. We'll place it so that there is only one non-zero digit to the left of that decimal point. And then we'll make a change, so what we have to do is count the number of decimal places the decimal point has moved from the original. And this will be the exponent on the 10. And we're going to show all this with the actual numbers in just a moment. Now, if the original number was less than 1, then the exponent is negative. If the original number is greater than 1, the exponent is positive. So it might help to watch the first couple here, then maybe pause the video and try them on your own. So the first number, 0.0000072. Well, if we look back at what was said a few slides ago, I'm going to change it for you guys real fast. The decimal point gets moved to only one zero digit. It's to the left of that point. Back here. So I take this point, I'm just going to move it. Okay, 1, 2, 3, 4, 5, 6, 7. 7 places. So now we have 7 2/10. And we know it's going to be times some power of 10. And as we said, the number of places the point moved becomes our exponent. 1, 2, 3, 4, 5, 6, 7. And since the starting number was less than 1, the exponent is negative. So this is our final answer. Now the other way. So our number here, 480,000, not a hard number to work with, but we want to make it smaller for scientific notation. So decimal point is always at the end there, if we have a whole number. It moves 1, 2, 3, 4, 5 places. So we have 4 8/10 times 10 to the 5th power. And since the number is bigger than 1 to begin with, the exponent stays positive. If you want to grab a calculator and check these out, you can to verify that this works. I have no problem with that. And number 3, decimal point is going to move. We only have one number left of the decimal point. So move it 2 places. So we have 9 83/100. The point moved over 2 places. And it was less than 1 to begin with. So we have 10 to the negative second. So there, let me rewrite that -2. It looks kind of sloppy. That is converting numbers from standard form into scientific notation. And now we'll go the other way. So from scientific notation to standard form. So what we do, I always write the original number, 4 89/100. If we know it's going 10 to the 7th power, we're multiplying that. That tells us the decimal point is going to move over 7 spots. Because it's positive, we go to the right. So we go 1, 2, 3, 4, 5, 6, 7. Any empty buckets there? We add zeros. And there's our answer. 48,900,000. Now we have 1 4/10 times 10 to the -8th power. The -8 tells me we're going to go to the left. So we write that number, 1 4/10, and the point moves over 8 spots to the left. 1, 2, 3, 4, 5, 6, 7, 8. Empty buckets, place zeros. So we have a really small number here. And the last one, you want to try on your own if you haven't already been doing so. Original number written down. It moves 5 spots to the right because the number is positive. 1, 2, 3, 4, 5. Fill the zeros in. So that is scientific standard. And the final thing that we're doing here are the following numbers in scientific notation. Why or why not? Well, the first one, look at it, it's not, because that number is bigger than 10. The next one is not as well. This needs to be a whole number, or an integer, excuse me. And the last one looks good to me. This concludes your lesson on scientific notation.